Welcome to The Explainer. Today, we're diving into a field that's becoming, well, absolutely critical for everyone in tech, green software engineering.
Let's just kick things off with a number that might surprise you. 3.7%. That's how much of the world's global carbon emissions come from the internet. Now, to put that into perspective, that's actually a little bit more than the entire global aviation industry.
And this brings up a really critical question for all of us in the tech world. Are our apps, our architectures, the very code that we write every day, are they contributing to this massive invisible footprint? The short answer is yeah, absolutely.
Okay, so let's really get into it. First, we have to understand the problem, which is the massive and often totally unseen environmental cost of software.
See, every single line of code runs on physical hardware, right? And that hardware consumes electricity, which, let's be honest, often comes from burning fossil fuels. And every one of those servers, eventually, it becomes e-waste. This whole life cycle has a real, tangible cost to our planet.
But here's the hopeful part. What if we could actually design, build, and run our software to be more sustainable? That is the absolute core idea behind green software engineering. It's all about shifting our mindset and our methods.
And look, this isn't just some vague, feel-good concept. Nope, it is a dedicated engineering discipline. It's about treating sustainability as a core priority right up there with performance and security. And it's all guided by a clear set of key principles. So what it all boils down to is really three things. First, being energy efficient. That means writing code that sips power, it doesn't gulp it. Second, being hardware efficient, getting the absolute most out of the machines we're using. And third, being carbon aware. This one's cool. It means timing your computing jobs for when the power grid is being fed by renewables like solar or wind.
So, how does all this theory actually translate into practice? Let's take a look at how these principles really apply to the code we write and the systems we design every day.
Now, this is really interesting. The choice of programming language itself can have a measurable impact. A recent study showed that for the exact same back-end job, a Java application consistently used less energy and less memory than an equivalent one written in JavaScript. That decision, right at the very beginning of a project, really matters. And then at the architectural level, seemingly small changes can have a massive impact. A classic example of this is moving away from constant API polling, where a client is just endlessly asking the server, anything new? Anything new? How about now? And moving to an event-driven model where the server just says, hey, here's something new, but only when it's actually needed.
And this quote just brilliantly illustrates the waste. Almost 99% of those polls are for absolutely nothing. It is exactly like a kid in the back of a car asking, are we there yet, every 5 seconds on a trip that's hours long. You're just burning energy for no reason. And other modern patterns help out a ton too. Serverless architectures are great because they stop us from powering servers that are just sitting there idle. Edge computing cuts down on all that long-distance data traffic. And of course, well-designed microservices let us scale only the specific parts of our app that need it, which maximizes our resource use.
Okay, so we've seen the principles and the practices, but how do we actually prove that our changes are working? How do we know we're making a difference? Well, we have to measure our impact.
I mean, this is the fundamental principle of this entire process, right? Without data, we are just guessing. We have to find a way to quantify our software's carbon footprint.
Now, you might have heard of the greenhouse gas protocol for measuring a whole company's carbon footprint, but for this, we need something more precise. So the Green Software Foundation developed the SCI specification, and it's designed specifically to score the carbon emission rate of a single application.
All right, now this formula might look a little intense at first, but I promise it's actually elegantly simple once you break it down. It's all designed to turn a big total emissions number into a rate, kind of like miles per gallon for your car. And a rate is something you can actually work to improve.
It all starts with E for energy. That's just the raw electricity in kilowatt hours that your software is consuming.
But we all know not all energy is created equal. So we multiply that by I for intensity. This basically measures how clean or dirty the power from the local grid is. This ties right back to that idea of being carbon aware. You want to run your code when I is low. Next, we add M for embodied carbon. Now this part is fascinating. It actually accounts for the emissions from manufacturing the hardware itself. It's a powerful reminder to be hardware efficient. And finally, to turn all of this into that useful rate, we divide everything by R, our functional unit. This could be anything, per user, per API call, per transaction, whatever makes sense for your app. So, calculating your score really just involves 4 key steps. You define what part of your system you're actually measuring, you choose your functional unit, you figure out how you're going to get the data for E, A, I, and M, and then you quantify the result. So, why does all of this matter to you? Because building green software, it isn't just about doing something nice for the environment. It's really about a deep commitment to engineering excellence.
I mean, think about it. Efficient, sustainable code is pretty much always cheaper to run. It uses less energy, less hardware. It's also often more performant, which means faster load times. And all of that just combines into a better product and, honestly, a better reputation for your brand. So I'll leave you with this challenge. Think about your own work, the application you know best. What is the single most inefficient process in it? And what would it actually take to change it? Because answering that question, that's the first and most important step we can all take toward building a greener, more efficient digital world.